Today we're going to look at the LM13 frequency meter. This is a unit that's very similar to the BC221 frequency meter, or heterodyne frequency meter as they call it on the book, and they do virtually the same thing. Whilst a lot of people might be familiar with how one selects the frequency on these dials, we're going to spend a bit of time going through that as we do it, simply to make it quite clear. Now, a very important thing to say is the book that comes with it, this is the book that comes with it. If you do not have the book that belongs to your particular unit with its serial number, then in all honesty there's not a lot you can do with it, because all the readings in here are taken specifically for this unit. They will not work accurately with any other one like this at all. That's why on it has the number 8201, which is the serial number of this here. So the question is, what can you do with one of these? Well, a lot of things. Particularly if you take the things mentioned in the front of the book, you can set a transmitter up on a specific frequency and know it's going to be on that frequency, or you can set a receiver up to receive a certain station. If you know a certain station will be broadcasting on a certain frequency at a certain time, you can check the accuracy of your scale, and by setting this up to the frequency you want, you can pick it up on the receiver and you can wait on that frequency and know that you're going to hear those signals when they come in. In keeping with the BC221 frequency meter, which is very, very similar in layout, it too has exactly the same way of selecting the frequency. The frequency you want is selected on these two scales here. One is this little window that gives you your hundreds, and this one gives you your units. We'll notice that this one, we have it currently set on about nearly 16, so that's 15 to 20. This is actually on 0. Now, this, for people who are unfamiliar with it, this is a scale here, this vernier type scale, allows you to actually work out where you are. So for example, that might be 0, that might be 1, but in between 0 and 1 there are in fact 10 steps. And the 10 steps are designated by this upper scale. So if for example we take 5 lines up with 5. None of the other ones you can see here line up with each other. 0.5 is halfway, which is here. And you'll notice that now the 5th mark, 1, 2, 3, 4, 5, lines up with the 10, because the 10 doesn't matter what the number is, it's the fact that it lines up. And you'll notice as we shift, that is now in the middle. If we shift it down to make it 0.4, you'll notice that the 4th digit now lines up, corresponds. Or go the other way, if you want the 8th one, the 8th digit will correspond by the time we reach what would be the 0.8 setting. So that is 0.8, and you can actually see that the 8th, that's 5, 6, 7, 8, 8th one lines up with any other digit on the bottom. All the rest do not line up, and that is how it works. Now the figures in the book will be usually either 3 or 4 digits long plus a 10th. So in other words, you would have 4 digits and point something or other. For example, this here at the moment will be reading 15, 16, 16, 17 and something. So the and something is that, which would be 05. So this particular reading we're looking at, assuming we don't have a fraction here, would be 1705. So 1705 point nothing. If we move that to halfway there to give us the 5, that's a half of that division, it'd be 17055, because that is the 0.5. So 1705.5. If that makes sense, we'll have a little look at the book now. Thing that we do first of all will be to calibrate this unit. This unit here, by the way it bounces is because it's on the original shock mounts. It does look a little strange when it bounces around. What we do now is we'll move on and have a look at the crystal calibration. The correction knob here called corrector, this is the one knob which we'll adjust to try and peak tune the variable section here with the crystal. Now in order to do that we have to find what's called a crystal checkpoint, and on the front of the book they talk about crystal checkpoints. Now what we're going to use today is just for an exercise. We're going to try and tune our receiver over here to 5.3 megahertz. Now there is no crystal checkpoint for 5.3 megahertz, so therefore we set up the frequency meter and check it up against the nearest one we can, which happens to be 5.5 megahertz. So what we'll do first and foremost is we open the book. I put the marker in there so I can find it easily, and I'll show you 5.5 on the close-up. Here we have the top of page 22. The red entry here is a crystal checkpoint. It says at the bottom of the page the ones on here is 2750, 5500 and 11 meg, which we can see there's 11, there's 2750 and 5.5 meg. The dial reading, this was done on an automatically set up printing device which would run through all the frequencies and stamp this out like a computer, I guess you could call it, a World War II computer. And this is giving us that reading I was telling you about with the 4 digits. We have 2012.9. So the 20 would be on the little window to the left, which we showed you. We'll have another look at it in a minute. And the 12.9, 12.9 is on the big circular dial. The 0.9 we pick up on that vernier I was explaining. So let's have a look at the front of it again. Here we go. So we know it's 12.9, so this needs to be increased to 20. That's 20. And that should correspond, there we go, to 0. So we know that would be 20000. But we want 2012.9. So that's 20. So we now set the inner one to 12, which is 5, 6, 7, 8, 9, 10, 11, 12. Now it's nearly 13, so we want the 0.9. So we watch for the 9 to come up there. So that's 12, 13, and the 9 is just there. So the 8 is out, 7, 6. You can see the only one that's actually corresponding is the one just before. So that is 2012.9, which is what the book calls for. So what we do now is we turn on the crystal. Now I'm turning on the crystal. We know the crystal frequency is this. And turning it on now, we first of all need to plug in the phones. We won't hear a thing. There's the phones, plug in the crystal. We hear a noise on the phones. Now it's obviously not far out. What we do is we beat the two frequencies against each other using the corrector here. That's it, done. When you reach the null, you know you are spot on, which means our corrector has now corrected it as close as we can to what we want. So what we now do is we look up the next setting in the book. Okay, so what we want is we're going to have 5.3 meg we want to set our receiver up to. So we look through the columns until we come to 5.29, 5.28, 5.3. There we go. So it's 5.31, 5.32. We want 5.3 meg. So that is on that top line there. Let's have a look at that closer and see what settings it's actually calling for. So 5.3 meg. 1801.9. So we now need to set the dial up to 1801.9. Remember, the crystal's off, phones are out, modulation's off, we're on the high frequency range, corrector we don't touch. So let's have a look at that. 1801, so this needs to go down to 18. Remember, this bounces around a bit. Right, that's 15, 16, 17, 18. That's 18. There we go. That's 0 on there, which is fine. That's 18, 0, 0, 0. 1801. So 001. And 0.9 takes us up to there, which is almost not quite the next mark. So that's it. That's set to 15, 16, 17, 18, 01.9. There we go. That's what all we have to do with this unit. 1.55 is here, so we need 5.3. If we now adjust the dial, we should pick up the carrier from the frequency generator. So that's 5.5, 5.4, 5.3, that's it should be. Oh, there it is. We put on the modulator here, we can actually have a tone. So it shows there is an inaccuracy in our scale on the receiver. It's only a very, very small inaccuracy, but that's it. So we now know that we have set up the receiver. And turn up the RF coupling a bit. And that's all we have to do to set that up. So if we now turn off the frequency meter, we can now wait for our station and hopefully we'll hear what we want to hear. Okay, if you're interested to see another one done from start to finish, here we go. Let's just choose another frequency as nearby, 4.1 meg. So if we look for 4.1 meg, we'll check the nearest calibration point on the unit using the crystal calibrator, and then we'll set it up and pick it up on the receiver. So we'll run through this. I'll tell you exactly what I'm doing as I do it. So if we make a start, we'll find that 4 meg, I've already turned to this page 15, 4 meg is actually on 403.9. Now that's only 3 digits and a decimal point. So that is 04039. So we put the crystal on, the modulation is off. We don't want that because the phones are turned off with the modulation on, so the headphones are on. We're still on the high frequency scale. The corrector we don't touch. The aerial is still connected up, although we're not using it at the moment. So what we'll do is we go through here. This says, as I said, it's 0403.9. So need to set that to 04. Whoops, we heard him go through it there. Unplug it in a minute. So that's 0403.9. 04 0123.9, and 9 once again is there, 0.9. So 03.9. Plug in the headphones. Adjust the corrector to correct this part to the crystal. So as low as it'll go there. That's as low as it'll go. That's done. Now that's 4 meg. We want 4.1, which is conveniently actually on the same page, except this time it's 05201. So we now go up a bit. So we're on 04. That's 0, 05. Oh, wait, 41. 05 20.1. 05 20, and the 0.1 comes up on the vernier. Tiny tweak, that's it. 0520.1. So that, if we now turn the crystal off, that should be coming out down the aerial lead. So if we turn this, 4 meg is up here. Let's turn up the volume a little bit. You can hear it, or if we turn the modulation on. So let's zoom in on the frequency. Not bad, it's almost spot on 4.1 meg. There we go, so that's our demonstration of the LM13 frequency meter. We're using an R1155 XREF receiver to pick it up. Hope that's been of some help and interest for anybody wanting to know how one uses one of these. Thanks for watching.